Hi guys, so we're back with another video. This is the part two. If you wanna watch the first one, it's there. Um, all right, so as we ended up here, like on the second paragraph, uh, the how the how the concepts are undergoing reinterpretations. Let's move on to the third paragraph. So, as it says, this evolution can be easily traced over the past 20 years or so as we follow the progression of the various industry technologies. From the first primitive browsers of the mid to late 1990s, the mobile phone web applications that dominate today. So it says that it's been for quite a lot of time. It's been 20 years, and so it's how long it's been there. He's kind of explaining that, and it says that every other um, platform where application runs, the object-oriented technology, the whole paradigm kind of dominates. That's what he's trying to say here. And then he goes on to say new developments are just around the corner as we explore hybrid apps and more. So uh, yeah, okay, so then throughout this journey all concepts have been there every step of the way. That is why the topics of this chapter are so important. The concepts are just as relevant as it were 20 years ago, so that's okay. There's nothing much to learn over here except that it's been there for 20 years and it's mature now. The fundamental concept. So the all right, the primary point of this book is to get you thinking about how the concepts are used in design object-oriented systems. Uh, so when you design object-oriented system, what are the concepts that are used uh, while designing the system? That's what this book is going to introduce you about. Object-oriented languages are defined by the following, like encapsulation, inheritance, and polymorphism. So these are the three parameters that object-oriented programming has. And then thus, if a language doesn't implement all of these, it is generally not considered object-oriented completely. So these are the three keywords that a programming language should provide. Not keywords, key features that a language should provide to be called object-oriented programming language. So not completely object-oriented. I guess completely object-oriented is when everything in the language is an object. It allocates heap memory. It deals with heap memory instead of the stack memory, the run stack. Uh, that would be purely object oriented or completely object oriented. So if you are thinking of a language like that, it would be Smalltalk, as I said. But yeah, if these three are there, I mean, you can implement these three features in a language, so it's object oriented. All right, so along with these three terms, I always include composition in the mix. So yeah, so composition kind of has a story with inheritance. We'll look at that. Probably this book will kind of show us how it is related. So that's how he entered. That's why I guess that's why he highlights composition, I guess. So all right, let's go on. So sorry. All right, so he says that thus if a language implements all the four, it's object oriented programming language. So all right, so we'll discuss all these in detail as we proceed through the rest of the book. All right, okay. So one of the issues that I have struggled right from the first edition of this book is how these concepts relate directly to current design practices. So that is why I'm covering this book. As I haven't covered this book, I mean I haven't read this book. Kind of as he introduces this book, he goes on to say that how can you design a project with these concepts. That is what he is gonna introduce us to. and not some blind how to implement inheritance, how to implement polymorphism, sorry, something like that, or composition or encapsulation, but what it is and where it should be used and how it should be used. That is what you should learn independent of the technology, such that if somebody hands you that you have to implement O in a web platform, or you have to implement O in a mobile platform, or you have to implement O in a desktop application, or maybe XYZ device, you should be able to implement it uh, uh, and analyze the technology, whether the technology can implement it. And if the technology can, then you should be able to design on uh, I mean, you should include all the design best practices and design object-oriented system. I guess you kind of get the feeling of what I'm trying to say. It's not about the technology, not Java to implement O. I mean, even JS can implement O, or the Python can implement O. So it's not the technology, the concepts that matters. That this book kind of gives you that. So, all right. So does inheritance break encapsulation? See, these are the things that we're gonna get. You don't get these kind of things through YouTube videos and all. Like, I mean, uh, sorry again. So does inheritance break encapsulation? This topic will be covered in the later chapters. Even now, many developers try to avoid inheritance as much as possible. Guys, I confess to this. I see a lot of inheritance in almost every Java project. I am not a Java developer, but then in JS as well, there are a lot of inheritance being used. Mm, so he says that it can be, you know, what you call, there can be a difference in opinion while implementing inheritance. So we'll be seeing how it differs. All right. Now my approach is always to stick to concepts, whether or not to use inheritance. You at least need to understand inheritance, thus enabling you to make an educated design choice. All right. So let's, as mentioned in the introduction, the intended audience is those who want a general introduction to fundamental O concepts. With this statement in mind, in this chapter, I present the fundamental object-oriented concepts with the hope that the reader will then gain a solid foundation for making important design decisions. The concept covered here touch on most, if not all, of the topics covered in subsequent chapters, which explore these issues in much more detail. Alright, so these are the four technologies, these are the four features that kind of decides whether a language is object oriented or not. How, and then he goes on to say that you kind of I'll kind of introduce you to all these features, and then we'll discuss the pros and cons of these features and what to do to get the most out of it. And as he says, after reading this book, you will get a solid foundation for making important design decisions. So that's what I'm looking for, to foundation for making important design decisions. All right. So let's go. It says objects and legacy systems. As O moved into mainstream, one of the issues facing developers was the integration of new O technologies with existing systems. At the time, lines were being drawn between O and structural programming, which was dominant development paradigm at that time. I always found this is odd, because in my mind, object-oriented and structural programming. Yeah, this is quite an interesting topic, guys. Like, when O came into existence, like when Alan Kay introduced O programming, the thing that was previously there was structured programming. And if you know structured programming, previously, prior to structured programming, there wasn't even a paradigm. People used to code in machine languages, and it was hard to write code. mm, Only I mean pretty good minds could write code, I guess. And then he started to, like, there were go-to statements being used and all. And then Dijkstra came along, and he kind of introduced this structured programming languages. I kind of removed the 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 difficult part of the programming, and introduced uh, and started to say that how a program, I mean, he kind of what do you call, uh, mm, I guess he introduced that even uh, even anyone can write program, I guess. So that was his intention, and he kind of introduced the structured programming language. And then it was there for quite a lot of time until Alan Kay came along, and he introduced object-oriented concepts. So you see, that is what he's trying to say over there. The concepts evolve when you find a difficulty, when you find a what do you call, gone, when you find uh, what do you call, the disadvantage, then you kind of evolve it to make it better. So that is where Alan Kay came along and introduced object-oriented programming languages. So previously it was procedural programming or structured programming that Dijkstra introduced, and now it is object-oriented new concept. So that is what he's talking about: objects and legacy systems. So all the legacy systems that were there, uh, they kind of wanted to change it to the OO paradigm. So lines were being drawn between structural programming and OO programming, which was dominant development paradigm at that time. I always found this is odd because so he says that even object-oriented programming has structures in it, has functions in it. So they complete each other and not compete each other. They're complementary because objects integrate well with the structured code. Even now, I often hear the question, are you a structured programmer? He says both. So, okay. And then, in the same way, an object-oriented code is not meant to replace structured code. Many non-OO legacy systems are doing job quite well, so why risk potential disaster by changing and replacing them? So this was written in 2013, I guess, this book. And even at that time, structural programming, I guess, existed, and even now exist as well. Like if you look for the uh, legacy systems, they kind of designed with the structure paradigm in mind. And he goes on to say that you shouldn't replace them if they're working well, but yeah, if you are adding new features or creating a new one, you should use OO. So in most cases you should not change them, at least not for the sake of change. There is nothing inherently wrong with system non-OO code. However, brand new development definitely warrants the consider of using OO technologies in some cases. There is no choice but to do so. Alright, I guess he goes on to talk about what are those choice. So although there has been steady and significant growth in OO development in past 20 years, the global community depends on networks such as internet and mobile infrastructure has helped uh, okay, so has helped catapult it even further into mainstream. Alright, he goes on to repeat the same, that because mobile and web uh, came into existence there for 20 years, the literal explosion of the transaction performed on the browsers opened up brand new markets where much of the software development is new, mostly unencumbered by legacy concerns. Even when there are legacy concerns, there is a trend to wrap the legacy systems into object wrappers. So yes, it kind of got famous, even legacy systems started to shout that people